Hello everybody, today we are working with rational exponents and radical expressions. I can apply exponent rules to rational exponents to simplify expressions. So the very first thing would probably be, what are rational exponents? Rational exponents is just where you have a rational number as an exponent. You're probably thinking like, yeah, that's pretty obvious, like that makes perfect sense, but like what does that even matter? Well, the first question would be, what is a rational number? So rational numbers could be integers, they could be like fractions. So today what we're going to look at is if I had something that had a m to the n, the way that you would write that is that you have n root a to the m power. Or you could say n root a to the m power without doing a whole entire big parentheses around it. This is basically just saying a to the nth root and then to the m power. So whatever m would be your power. So use exponent rules to explain why these expressions are similar. So looking at these two, what kind of what rule are we looking at? The product rule, power rule, quotient rule, negative exponent, zero, power of a product. Well, looking at it, it looks like to me we have the power rule. And what was the power rule again? It was b to the m to the n. How do we solve that? B to the m times n. For this whole entire thing, you're probably going to just want to keep out that page that says what exponent rules do we need, which was in the previous or last week's packet. Okay, so looking at this, we have 5 to the 1/3 times 2. And they're saying that equals 5 to the 2 times 1/3. Does it really matter what the order is? No, because they're both going to give you the same exact thing. It's going to give you 2/3. Okay? Okay. So, exponent rules and rational exponents. This very first one is probably the hardest one that you're going to see. So let's just go ahead. I'm going to tell you. I want to make these both have the same base. So the 5 and the 25. How can I make 25 look like 5? Well, 25 is just 5 squared, right? So really, I have 5 to the 5/6 squared times 5 to the 1/3. So does everyone see where that came from? I got this 5 from saying 25 is equal to 5 squared. Okay, so now, going back to my product rule, 2 times 5/6, so 2, oops, wrong part. 2 times 5/6. So all we have to do here is think this is 2/1. So let's multiply straight across. 2 times 5 is 10. 1 times 6 is 6. So I'm going to write I have 5 to the 10/6 times 5 to the 1/3. Now, what do I have to do? Well, I could change everything so that they're all into thirds, or I could switch everything so they look like they're all 6. I think this 5/10 right here, or 10/6, I think that I can simplify that a little bit. So if I divide both of these by 2, so I have 5 and 5/3, right? Times 5 and 1/3. Now, do both of my exponents have the same base? Yeah, they both have a 3. So I'm going to have 5. And then looking at this one, doesn't this look a lot like the product rule? So the product rule says that we're going to add our two exponents together. So 5/3. So I'm just going to write, oh my goodness. So I'm just going to write this as 5/3 plus 1/3. So let's just go ahead and add these together. 5 plus 1 is 6. And then the 3's we're not going to add together. It's just going to come along. So we have 6/3. How can I simplify 6/3? Isn't it just 2? Okay. And then one more time, what's 5 squared? It's 25. This is your final answer. So everything that I'm doing is just based off of the exponent rules that we have written before and we should already know how to do. Okay, so looking at this next one, I have 8 to the 1/2 over 32 to the, okay, so let's multiply these together. We have 2/5 times 1/2. 2 times 1 is 2. 5 times 2 is 10. We can simplify this down a little bit and call this 1/5, right? So 32 to the 1/5. Okay, now, an interesting thing about this, 8 to the 1/2, so thinking back to the very beginning, it says we put the bottom number as our root. So we have a square root of 8 over 5th root of 32. And then you can put ones. We don't need ones though. Okay, so now it seems like we are simplifying radicals. The best way that I think to do it, and the easiest way, is just 8, and then you do the tree method. So you always use 2 first, so I'm going to put in a 2, and 4. 2 times 4 equals 8, right? Now I can split up 4 some more. 2 and 2. 2 times 2 is 4. 2 times 4 is 8. Now, we are looking for pairs. So I'm going to put a square or a circle around my pair. So I have a couple of 2's. I have one more 2 that's just kind of sitting out on its own. I'm going to put a box around that 2. The way that you do this with radicals is it's the circle on the outside, square root, and then box on the inside, okay? So the way that we're going to write this is we have 2 radical 2 over, now 32. Let's go ahead and split that up. We have, I'm just going to write it over here, 32. The numbers that go into 32 are 2 and 16, 2 and 8, 2 and 4, 2 and 2. Okay, so one more time to make sure we know how this works. 32, I tried to pull out a 2 and it worked. It gave me 16. 16, tried to pull out a 2, so 16 divided by 2 is 8. Okay, so now I'm taking this 8 divided by 2, give me 4. 4 divided by 2 gave me 2 again. So what we're going to do here is we are looking for the 5th root, right? So I'm going to circle how many of these there are. So 1, 2, 3, 4, 5. These all are going to go on the outside. And by that, I mean just one of them. How many circles do I have? I just have one circle. So I'm going to put 1, 2 on the outside. Square root. Do I have any boxes over here? No, I don't. So my answer is just going to be a plain 2. Can I simplify this any more? Yeah, I can. This 2 and this 2 cancel. So I have radical 2. That is my final answer. Okay, these ones are a little bit harder just because they're actually like full-on numbers. The next ones are going to be with variables. So let's go ahead and take a look at this. We have xy to the third over x to the half, all to 2/3. So very first thing we're going to do is we are going to distribute this 2 halves to everything that is on the inside. So we have x to the 2/3, y to the 3 times 2 is 6 over 3, and then over x to the 1 times 2 is 2, 2 times 3 is 6. Okay, so let's go ahead and simplify this a little bit. X to the 2/3, y to the 6 divided by 3 is just 2, all over x to the 2 over 6. Okay, so looking at this, my x's on the top and the bottom, what does that mean we have to do? That's my quotient rule. So that tells me that I have to subtract. So I have 2/3 minus 2/6. Now, I can't subtract, or I can. Okay, so I have 2/6, which is the same thing as 1/3, right? So I have 2/3 minus 1/3, which equals 1/3. Okay, so I have x to the 1/3, y to the second. So one more time, just to make sure that we all understand this, I took this number and I subtracted this number because they have the same base. They both have x's. So when I did that, that gave me 1/3. So I put that right there with the same base. And then y squared, there was nothing to do with the y squared, so I kept it the same exact way. Okay, so now let's try this next one. We have 2a to the 1/3, because nothing's happening to that, times a, let's go ahead and multiply this out, so that's 2/3, b to the 1 times 2 is 2, 2 times 3 is 6. Okay, so looks like we have 2a to the 1/3, a to the 2/3, b to the 2 divided by 6, that is 1/3, because 2 goes into 2 and 6. Okay, now looking at this, how can we simplify this more? That looks to me like the product rule. The product rule just means that I am adding. So I have 2a to the 1 plus 2, that is 3/3, b to the 1/3. Now let's just go ahead and simplify this. 3 divided by 3 is just 1, so 2a times b to the 1/3. That is what we are looking for. Okay, so we just skipped the last question. I want to go to the next page. So 3 to the 5th to the 1/4. We're going to just multiply these two together. So 5 times 1/4. So that tells me I have 5/4. So that just tells me my final answer is 3 to the 5/4. So again, the power rule tells me that I'm multiplying things together. Okay? Okay. So the next one. Well, first, everyone take a look at the bottom part. Let's go ahead and just write out what these answers should have been. I'm guessing that your paper does not show them again. So A is x to the 5/4. B is just a plain x. C is x to the 13/2. D is x to the 5/4. E is x to the 2/3. And F is x to the 1/8. Okay, so